All right, if you're building anything for the Internet of Things, you've definitely heard of the ESP32. I mean, it's that powerhouse microcontroller that basically brought Wi-Fi and Bluetooth to the masses, right? But here's the thing, the ESP32 isn't just one chip anymore. Oh no, it's a whole family, and it is growing fast. So today, let's break it all down and figure out which one is the perfect ESP32 for your next big project. And yeah, that really is the big question, isn't it? You've got Espressif putting out nine distinct versions of the ESP32, and each one is tweaked for a different job. You've got the original classic, you've got specialized chips for AI, for smart homes, for high-performance video. I mean, picking the right one can feel, well, a little overwhelming. So how on earth do you choose? Okay, so before we dive in deep, let's just do a super quick refresher. What even is an ESP32? Well, at its core, it's a low-cost, super powerful system on a chip, or SoC. But what made the original such a game-changer back in 2016 was that they crammed Wi-Fi and Bluetooth connectivity right onto the chip itself. All of a sudden, for just a few bucks, anyone could build a connected device. It just completely changed the game for the whole IoT and maker community.
Absolutely.
Okay, so here's the secret. The best way to make sense of all 9 of these chips is to just split them into 2 main families. It all comes down to their core architecture. Think of it like 2 different branches of the same family tree, you know? Each one has its own strengths, its own personality. So, first up, we've got the Extensive Performance series. This family, this is where it all started. It includes the original ESP32, that dual-core beast that can handle your app logic and the wireless stack all at the same time. Then you've got its siblings, the S2, which goes all in on low power by dropping Bluetooth, and the S3, which is another dual-core monster that adds AI acceleration and vector instructions. This thing is perfect for more complex stuff, like, say, smart cameras or voice assistants. Now, the second family, this is a huge deal. It marks a major shift over to RISC-V, that open-source architecture you've probably heard about. And really, this family is all about the future of IoT. You've got the C3, which is a great, secure, affordable entry point. Then there's the C6. Oh man, this is the smart home champion, built for the Matter standard with Wi-Fi 6 plus Thread and Zigbee. Then you've got the H2, which gets rid of Wi-Fi completely to become a low-power mesh networking master. And then there's the P4, which is just an absolute monster of a chip built for one thing, pure performance. And that brings us to a really fascinating showdown. You know, to really get the design philosophy here, we need to put 2 of the most capable chips head-to-head. In one corner, we have the AI-powered all-rounder, the ESP32S3, and in the other, the new performance specialist, the P4. Let's get into it. Now listen, this is not a simple upgrade. Don't think of the P4 as just a better S3. Nope. These 2 chips are built for completely different battlefields. The S3 is all about integration, right? Packing everything you could possibly need for an AIoT, or artificial intelligence of things device, onto one single chip. The P4? It's about the exact opposite. It's about stripping everything non-essential away to focus on just one thing: raw, unadulterated processing power. Okay, let's look at the specs, the nitty-gritty. The P4's RISC-V core, it runs at a blistering 400 megahertz. Compare that to the S3's 240. But, and this is the crucial trade-off, the P4 has 0 built-in wireless. None. It's a pure microcontroller. The S3, on the other hand, is a true system on a chip, with Wi-Fi and Bluetooth baked right in. And then check out the multimedia stuff. The P4 has dedicated hardware for video encoding and modern display interfaces. That makes it a total specialist for what we call human-machine interfaces, or HMIs. You know, things like industrial control panels or those fancy smart home displays. I just want to pause on this number for a second. 400 megahertz. That makes the ESP32P4 the fastest, most powerful chip Espressif has ever made, period. It's designed specifically for tasks that would bring other microcontrollers to their knees, things like real-time video processing or driving those beautiful high-res touchscreens. So here's a great analogy that really nails the core difference. Think of the ESP32S3 as a high-performance sports sedan. It's fast, it's comfortable, and it has everything you need: the engine, the navigation, the sound system, all built right in. The ESP32P4, that's pure specialization. It's just the race car engine. Unbelievably powerful, sure, but it needs an external chassis, like a companion chip, to handle things like wireless communication. Okay, so with all that context, how do you actually pick the right chip for your project? Well, it really just comes down to one thing. What are you trying to build? So let's walk through a super clear, practical guide. All right, here it is, your official cheat sheet. If you just need a classic connected IoT device, honestly, the original ESP32 is still a fantastic, super cost-effective choice. Now, if your project involves AI, a camera, or just tons of sensors, the ESP32S3 is your powerhouse. It's got the most I/O pins. Those are the general purpose input/output pins, a whopping 45 of them. Building for the future of the smart home? Then the ESP32C6 is really your only choice. It's ready for the new Matter standard right out of the box. Need to drive a really complex display? That's the ESP32P4's job, no question. And finally, for a tiny, battery-powered mesh device, the Wi-Fi-less ESP32H2 is absolutely perfect. And hey, for any battery-powered projects, you know that every single microamp matters. This is where those newer RISC-V chips, like the C6, just really shine. In deep sleep mode, they can draw as little as 5 microamps. I mean, that's a massive improvement over the original. We're talking about devices that can last for years on a single battery. You know, this quote from the source material really just says it all. The question isn't which ESP32 is the best. The right question is which ESP32 is the best for my specific project. Every single one of these chips is a specialized tool designed for a very specific job. Okay, so let's bring this all down to earth. Let's see how these choices actually play out in a real-world application. I mean, it's one thing to talk about specs on a data sheet, but it's totally different to see how these decisions impact a real, complex system. So take a look at this industrial IoT project. You've got an ESP32 on a factory floor. It's collecting data from all kinds of sensors and those heavy-duty industrial computers, we call them PLCs. Then it sends all that data over a lightweight protocol, something like MQTT, to a central dashboard. And what does that do? It lets the operators spot potential failures before they even happen. Pretty cool. And the choice of which ESP32 to use here was absolutely critical. The team needed rock-solid Wi-Fi and good security, for sure, but they didn't need the crazy multimedia power of a P4. By picking the right tool for the job, they made a system that was both super effective and affordable. It's a perfect example. So there you have it. What started as just one revolutionary little chip has blossomed into this incredibly diverse ecosystem of specialized tools. Each one is ready to tackle a different challenge in the amazing world of connected devices. I mean, think about it. The kind of power that was once reserved for full-size computers, it's now available on a tiny chip that costs just a few dollars. From AI running on the edge, to next-gen smart homes, to complex industrial controls, the possibilities are just staggering. So really, there's only one question left to ask. What are you going to build with it?